In this lab, we apply the momentum principle, Newton's second law, for the analysis of the movement of a ball being thrown by a person. The mass of the ball was measured with a scale, and its diameter was obtained from measuring the circumference of the ball and applying the formula which relates diameter and circumference. The video was recorded with a digital camera at 30 frames per second. Using the software tracker, we set up the calibration length and also the reference axis. The movement of the ball was manually tracked frame by frame, and the X and Y positions were collected in a CSV file. In this experiment, we have the application of an initial force, and after that, basically the action of gravity and drag. Using VPython and considering Newton's second law, we constructed a computational model. Here we have some initial conditions: the mass of the ball, the initial position from data read from tracker, the initial velocity calculated from the first 2 frames, the setup of the constant of gravity, and here we have the main loop, where we calculate the weight force, the drag force considering a model proportional to the magnitude at velocity. We obtain the net force. After that, we update the velocity and position of the ball in the model. We'll draw the weight and the drag as 2 arrows, and we also show the graph the position of the ball obtained from tracker. And running this code, we obtain these figures, where the blue ball is the model and the red ball is the real data. And here we have the graph of the Y position. So here we have some data: the initial position 0, 0, the initial velocity in meters per second, and only for comparison, the same velocity in kilometers per hour. And it's interesting to see that we had a displacement of more than 3 meters in the x-axis and more than 4 meters in the y-axis, and a disagreement in position at the final time of 26 centimeters in the x-axis and 17 centimeters in the y-axis. The constant B for the drag model was obtained empirically. And it's interesting to see the effect of the drag. If we set up this to 0, we can run this code without drag, and we'll see a bigger disagreement. So in this lab, we observed the effect of drag. The model, considering only gravity, did not agree very well with the experiment. It's important to include the effect of drag, and some errors are caused by the camera movement in the video. You can see this camera movement here. But for me, the most important thing in this whole course was that from only these 2 frames, and knowing the mass of the ball and the rules of physics, we can predict the position of this ball with a small error, even considering all the problems in the experimental setup as the camera movement. Physics rules. Thank you.